Hey, welcome to a new video. Today we are still at S30 World in Holland. I'm just about to check out what has to be the coolest S30 based project I've ever seen and probably what the world has ever seen. We're going to head inside the workshop and take a closer look at all the details. All right, so we are here in the workshop. We've been given like full access to kind of break down and find out everything about this crazy project from the men behind it. Starting off with the heart, this is a billet blocked RB36, 480 horsepower NA, and that's all I'm gonna say right now because this is pretty much the most incredible thing I've ever seen in an S30. All right, so I'm here with Chris and Jon, the men behind this incredible project. And Chris, just briefly explain what this passion project is for you. What are you trying to achieve?
Well, it's just the car that Jon and I love. Jon is my friend, and we started this 4 years ago, and we hope that it's finished end of next year.
Right.
But Jon knows everything about it, and yeah.
All right, we'll switch over and take a look at all the details with Jon. All right, so I'm here with Jon, and I guess take it from the top because I really want to find out everything, pretty much how the project came to be, I guess the direction you guys are going in, and all the details that came to be, because obviously you're creating something that's never really been done before, I think. So we really want to find out a bit of everything about it.
Okay, so the purpose of the car, it started in 2019. Just before the global pandemic, and we had brief discussions around what our ultimate Z would be. Yeah. And we quickly come to the conclusion that we were pretty aligned on what we want it to be. The whole ethos of the car is just lightweight, get it as light as we can. And the reason for that is because Chris had a billet RB30 cylinder block. So he'd been thinking about this for a little while. Mm-hmm. So I came on board primarily to take the project along, and we wanted it to be really special and design all of the parts made from the best materials, carbon composites, modern manufacturing technologies, modern design technologies. So we capture it in its time, yeah. And if we ever wanted to replicate it, we can. Mm-hmm. So the whole car is built under engineering change control. So if we wanted to revise something, we can up-revision the drawing and issue it to the suppliers, and the suppliers can make the parts. But there's a lot of bespoke parts in the car. I mean, our target weight was just over 1,000 kilos. So from a standard 280Z, roughly 1,270 kilos. But we're trying to get it to 1,050, but I'm quite confident we'll get it sub 1,000. Yeah.
Which is already incredible.
I mean, there's lots of big chunks that can be saved. Yeah. Like the cylinder block itself, you're saving 45, 50 kilos straight away. But replacing all the steel components with aluminium components, lots of use of titanium in the car, not only in the fasteners, but in some of the components in the suspension. There's lots of very bespoke suspension systems in the car. We partnered with a company in the Netherlands called Intrax, very good company, specified bespoke system for the car, but that's allied to the S30 World design hubs and uprights and everything. A very powerful braking system in the car, but one of the key characteristics of that braking system is that it had to fit within 15-inch wheels. We didn't want to, S30s look best with small or smallish wheels. Anything over 15-inch, in our eyes, just doesn't look right.
And I guess one thing I touched on with Chris over the last few days as I've been talking to him is that the fact that you're actually keeping the exterior of the car quite stock looking, very narrow body. And
well, the intention is that we want it to look like the best of all S30s. So this is a 280, not a 240. So we made our lives a little bit more difficult because the car's heavier to start with. We could have used the 240, we had a choice of two body shells that we wanted to use, or two cars at that time. but we decided it just didn't feel right to cut up a 240, or at least install a roll cage in it, a substantial roll cage in the car. So it was an you couldn't turn that back, so we didn't want to destroys the roll. We didn't want to use a 240Z, so we stuck with the 280. And we just wanted it to be looking like a period modified car, but to almost like a standard specification. Nothing outrageous, not really low ride heights, with the EU spec rear spoilers and the front air dams, nice Watanabe wheels, just so it looked, but to the untrained eye, it just looked like a standard car. But a nicely restored standard car. But when you look at the details of it, you would see that it's a bit more serious than that.
All right, well, that said, let's start looking at the roll cage.
Okay.
Because that's pretty.
So I think it's worthwhile just talking about the body shell for a second. So we have a process of sourcing cars. We have to source cars from dry state countries because of the rust issues, predominantly with these cars. So we have a standard document that we send to potential sellers of the cars with all the pictures in all the areas that we know are very prone to rust. It amounts to sort of 25, 30 photographs. And we ask them to take the same photograph back. And then when we get it, we review it and we say, yeah, okay, we think that's a good car. Because we have to buy them sight unseen.
Remotely, yeah.
And generally speaking, we don't catch a cold on that. We're pretty good at that. But this car is very rust-free. No Z is ever rust-free. But in terms of body shell, I think it's one of the best ones I've seen for a long time. There are certain areas in the car, there's some very slight accident damage on the back balance where somebody's reversed into something, a pole or a curb or something. But the usual areas where the battery is, you get the acidic rust there. But what we do with the car, we strip it apart and then we 3D scan the car. And then what I do with that 3D scan, I import it into CAD system, I can save that, and what I do is I mirror image the scan to see how straight the body is. And this car is straight, it's within 5 millimeters. So it's a factory specification car. There are some slight damages on the rear valance, as I said, but other than that, it was completely stock 280Z. And then we basically we partner with a company in the Netherlands to make the roll cage, Ad Verkeilen and Bart Verkeilen at VA Motorsport. They installed the shell, or designed the roll cage and fitted it into the car. And what you see is we focused on a couple of key areas. One is to move the driver as far back as possible. So you'll see when you come around here, the roll cage, we've put it through the rear wheel arch. You can see here. So it comes all the way down. So we've moved, this bar would normally go straight across, and obviously that bar goes straight across.
You kind of notch the wheel arch.
Yeah, you can't move the seat further back. So we've got another 10 centimetres of movement back, and we move everything inboard. You can see where it comes through. The whole body shell is stitch welded to give it strength, torsional rigidity. The roll cage is multi-pointed into the car. Everything is TIG welded. And what the first things we do is we make these chromoly top mounts for the suspension mounting points, and we just basically make sure that the car is going to be as stiff as possible. There's additional stiffening to the front suspension towers.
The strut brace.
Yeah, this is chromolybdenum steel that is welded in place. It allows for camber adjustment on the rear, and it stiffens the body shell. Obviously, the roll cage is tied into this area as well, so that stops flexing in the back of the car. Obviously, we have a cross brace for the seat belts. It's tied into the top of the transmission tunnel as well. So to stiffen this up area here. And also, if you look here, we go through and up to the suspension towers at the front, strut tops, and this goes down to the chassis leg as well. So this area is triangulated, and it's making it very, very stiff. We wanted to give up some a little bit of weight to make sure that we was much stiffer. We also
and up on this side.
We also come through from here to triangulate, so the two legs, if you like, are tied in. We remove the bonnet landing. Anything extraneous in the car is taken off. So any tabs, any bosses, any features that's not required, they just get cut off. It's quite interesting. We would go there, and the box of bits that they cut off the car was getting bigger and bigger every day. So it was good to work with these guys. They were very flexible. They accommodated some last minute changes. But you can see the stitch welding on the shell everywhere you go. And it's all TIG welded as well, it's not MIG welded.
Substantial job.
Yeah. We reinforced the anti-roll bar mounts. This is historically a weak point in these cars.
Yeah.
So there's a plate here and there's a plate on the bottom. Captive nuts as well.
Oh, true.
We have to cut the core support, I think, or slam panel, because on a 280 it has a bigger radiator and it drops down here, so you can see it from the front of the car. With the 240 it doesn't. So we'll replace this bottom part of the panel with the 240 one.
Yeah.
It's worth noting that the gauge thickness of the material on a 280 is thicker than on a 240, and that's why you make your life a bit harder to try and get the weight out of the car.
And I can see by these little stickers, he's 3D scanned everything.
Yeah, so we 3D scanned the car before to check its straightness, and then obviously we put the roll cage in it, cut the car about a little bit. To be fair, we not so intrusive, but we then 3D scan it as built, and then I do the same thing. I mirror the scan data and I see where it sits on top of each other. No negligible movement. So the car is straight, true, with a very stiff roll cage in it.
And start looking at the suspension and how it's all being changed, upgraded, and evolved. Right, okay, so I guess let's start at the front.
Yeah, so what we have, we've redesigned everything so we can manufacture it out of aluminium. So what we wanted to have is we didn't want electric power steering, we want hydraulic power steering. So we've gone hydro-electric power steering, so there'll be a pump mounted here that provides the pressure. So this is a steering rack for normally right-hand application that's flipped upside down and reversed for left-hand drive application. So everything is rigidly mounted, there's no bushes, this is bolted directly to this. But this 3D, this front cross member is a number of parts, so there's 5 or 6 parts in this. But the idea is this, is that you can take these off, take the lines off, drop the whole thing out. Yeah. And you can take the whole engine and gearbox downwards, because it's a bit tricky with the cross bracing in the engine bay.
Oh, I see, yeah.
So we drop the whole thing out the bottom of the car. So everything you see is bespoke. Uprights and the disc mounting bells, absolutely everything that you see is bespoke to this car. We designed, so I went round them because the original ask for the car was it to be very light, and it still is the original ask. So I designed these 5, 6, 7, 8 times, and every time I would put them through simulation. And not only for weight, but for stress analysis. And I could take weight out where I needed it to be and put weight back where I wanted it to be. But in the end, you end up going round and round in circles, and at some point in time, you just got to say enough is enough. The suspension is interesting. As I say, Intrax 4-way adjustable, so adjustable bump and rebound. Yeah. But also it's electrically controlled for stiffness. So we can change the stiffness.
From the cabin? From
the cabin. Yes, so we can manually change the bump and rebound settings just through changing on the remote reservoir canisters, but we can actually change the stiffness in the damper itself, and that will be adjustable on the fly in the car.
That's amazing.
Yeah, we have obviously a Bullet Racing RB30 cylinder block. We're going to go for 3.6 configuration, billet cylinder head, individual throttle body induction, dry-sumped, so we moved the engine as far down and as far back as we could go.
Yeah, and you can see here just how flat it is.
I'm sure people will look at this and say we can get it even lower, but the problem is that you've got to get the hydraulic fittings on the steering rack. Yeah. So at some point you have to say enough. Again, enough is enough. We have R34 GTT gearbox, so rear-wheel drive Skyline. We picked this gearbox, we went round and round discussing which gearbox to use. There was a number of different things that we were discussing, but these gearboxes are new and still available from Nissan. And also you can get close ratio gear sets if you want to. So this is just a standard gearbox at the moment. If we need to, we'll change the gear set after we start to do the tests and trials on the car. We've chassis mounted the engine. So you can see that the engine is bolted directly to the... It's not what you would call a stressed member, but the engine is giving more stiffness to the front of the car as well.
Amazing.
All the suspension is fully adjustable for camber caster.
Yeah, you can really dial it in.
Obviously tow in as well, but yeah, I mean we have our own Gearbox mount, you know, there's some 320 individual parts on this car that are bespoke to this vehicle. Okay, some of those are opposite hands, but they're basically bespoke. We drop the pedal box through the floor of the car because we have a floor-mounted pedal box that slides backwards and forwards. And this is not, it would normally look like this, it comes straight through. But we've cut it out of the floor, we've stiffened it, gusseted it. You know, this is much thicker steel than normal, so there's no loss of structural integrity. But also we have all the stiffening in the body shell around this area. So running through to the back of the car, we have a R200 short nose differentials, Nismo 1.5 way GT Pro LSD inside. But the housing is billet aluminium to save weight. And this is from a company in Australia. Obviously we have our own, what you would call differential cradle. What you see on the back is it's a little bit different than normal. So we have mounted our suspension, obviously using rose jointed system, to take out the centre bar here, so we can adjust toe on the end, and we can adjust camber and caster on the rear if we need to. Yeah. We have bladed anti-roll bar, so we can change that roll bar rate if we need to.
Amazing.
We've removed the spare wheel well in the car. This goes back to the 70s rally cars. We want to put a 100 litre tank in the car because we want to drive long distances. So that will have a body mounted sheet metal fabricated, baffled and foam filled fuel tank on the back. We make our own uprated stub axles and companion flanges. The serrations on this is for traction control, which will be controlled by the M20 ECU that we're going to use in the car. Yeah. But the focus is always electronic handbrake as well. So we take all the handbrake mechanism out of the car. You know, it's just literally one button, and so no handbrake turns.
The modern application, basically.
Yeah, and for me, it's a perfect, it's an ideal situation to save some weight. The brake caliper's tiny. You know, it doesn't carry any weight. You know, you're not carrying all their shoes, mechanism, handbrake, cables. You know, it's a good way to save weight. We've pre-stressed all the rod ends as well. So normally with a rod end, it's quite easy to move, you know, the body. But these are pre-stressed, so they're actually a bit stiffer to move, and that will give a much more sort of compliant ride to the car and hopefully take some of the crashiness out of it. Yeah. So we have AP Racing brakes front and rear, 310mm on the front, 310mm on the back. These are as big as they can be and fit inside the 15-inch wheels. We had a good dialogue with Watanabe themselves, actually, because I needed to design all because we're radial mounted calipers on our own uprights, and I needed to know exactly how big the inside of the Watanabe wheels were. And we had quite a conversation with them over a protracted period of time to get a drawing from them, and they provided a drawing, and then I could finalise the design and we could move to manufacturing. Yeah. Two-piece construction, obviously. They're not fully floating, they're bolted in position.
And you've gone for 4 pots front and back.
Yeah, so on the pedal box we have different size master cylinders front and rear, so we can proportional the amount of brake force front to rear. Through the engine ECU we have pressure transducing, so we can check how much ratio front to rear we've got. And also if it is too much rear braking, we can also reduce the amount of line pressure to the rear as well. So, you know, we can balance the braking exactly where we want, so we can bias it front to rear, and we can check that bias is correct. Because normal bias box systems, you just turn the knob and you think I'm somewhere, it feels a bit better, but you know, we like to deal in data and you know, exact.
A bit more modern approach, I guess.
Yeah, exactly. So yeah, we have slightly different piston diameters on the back, but the caliper itself is exactly the right size. Yeah. AP Racing are a great company to work with. They're very helpful. They provide CAD information. So, you know, in this world of being able to reverse engineer most things, a lot of companies are reticent to give you what they would consider IP or you know, information, but AP Racing, there are other companies that do it as well, but AP Racing were great. What do you need? What formats do you want out? You know, so, and that way you can place it exactly where you want it, especially when we're only running like 4mm of clearance into the inside of the wheel. That's amazing. It makes a big difference.
And then over to the rears.
So the rears are basically the same as the fronts.
Is it the same caliper?
It's the same caliper, but the pistons on the inside are smaller.
Right.
So there's not so much braking force on the rear, for obvious reasons, because obviously the back of the car is lighter than the front.
You can see that notch coming across here. Yeah. That we looked at before, the roll cage.
Yeah, it was interesting because when we went to VA Motorsport, to sign off on the shell, because when they work on a process where they stitch everything in place and then it's not finely welded, and we wanted to move the driver back with the setup there was more traditional setup. We said no, we want to curve the bars, so they were quite accommodating and they did what they want. And I think they may even use that same design feature on some of the other Datsun stuff they do now as well.
Nice.
But we make everything on the car, even down to the wheel nuts. The studs on the front are titanium, so these are very lightweight, high-strength titanium. So these are actually manufactured to suit. We can't do it on the rear because the rear is like the pushing studs.
But you're using a lot of titanium.
Yeah, so if you look on the car, so there's lots.
Package.
So the fixing stud and the nuts and there's loads of stuff. The turnbuckles. There's lots. We even make bespoke fasteners. Some of the fasteners on the rear of the car. So like these long bolts that go through the differential.
Yeah.
We have to make these fasteners ourselves. You can't buy them, unfortunately, because a lot of the titanium fasteners come from Motorcycle World. Yeah. And obviously they don't use bolts that sort of size and length, so that's bespoke to us.
And the one piece that's missing here is the prop shaft.
Prop shaft is carbon fibre.
Carbon fibre.
Yeah, it's being made in America.
Nice.
There's not any locally available people in the Netherlands to make it, so we just use the drive shaft shop in the States. We give them the measurements, we tell them exactly what's what, and they just make it to suit what we need.
Every single component has been
if you take
right down to
there's not one single piece in this car that's not touched.
Top efficiency. And I guess with that, we need to talk about the engine a bit more, I think, because
for us,
I like it a lot.
the engine is the jewel in the crown for this. We want, people see the car from the outside and they look at it and go, wow, that's a beautiful Z. And then it's just like the topping on the cake. You open the bonnet and you see this fantastic looking engine.
Speaking of the bonnet, actually, I think
it's carbon fibre.
Is that the one that's going to be used?
Yep.
Up here?
Yep. So we have carbon fibre for the bonnet, the fenders, the light cowls, the roof, the rear hatch. We're thinking to go carbon fibre on the doors, but the carbon fibre quality of the doors on the market, you probably spend more time getting them where you want them to be in terms of straightness to look like a steel panel. So we work with another company who also make who made all of these panels, and we're going to ask them to make the doors in carbon, we think. There's such a huge amount of weight. You pick up a 280 door, it's really heavy. You could probably save 30 kilos just by replacing the two doors.
That's wild.
But the door has to be the right quality, and we want the sound, when you shut the door.
The clunk.
The clunk, yeah. There's a few different ways of doing that, but if we have to give up a few kg and put some sound deadening in the door to give it some real stiffness, then we will. But we'll discuss with the company they're going to make the doors what we can do to try and make them as stiff as possible whilst retaining that lightness. Yeah. But this gives you a good idea of
Again, more titanium goodies. Wow, it feels like air. And this is this piece here.
Correct.
So we lowered the car and we got, I guess, the dummy side of the intake fitted. Yeah, let's run through all the details, because it is something unbelievable. I mean, I still can't believe I'm looking at this, honestly.
For us, the engine in the car really is the heart of the car. It's the jewel in the crown. You see the car built up at the side of a show or wherever at the side of the road, and you think that's a beautiful looking Z. And then when you open up the engine, the bonnet, bonnet this way, it's the real jewel in the crown. So the engine is the masterpiece of the car. It's the heartbeat. So the engine configuration that we're using is an all billet RB platformed setup. This is for mock-up purposes. So this is an RB25 Neo cylinder head. We're not using this. We're going to go with a billet RB26 cylinder head to our normally aspirated requirements.
Is that going to be like a custom design?
So we've partnered with a company, or two companies, one in Australia and one in New Zealand. JHH Racing, Will and his team there are going to build the engine. We've given them a technical specification for the engine, what our power and torque requirements are, and the characteristics of the engine. and we've just left them to get on with it. Kiwi CNC, who work closely with JHH, are going to be the people that make the inlet side of the engine, the induction side of the engine. That will be made to our specification in our drawings.
Yeah. So it won't look anything like this, basically.
It'll look similar, but not the same.
Yeah.
We have to realise some space constraints. So, because the engine is dry-sumped, to get it as far back and as low down as we can, we have to have a dry-sump tank that sits in this area here.
Yeah. Which is actually right behind us here.
Yeah, that's the two-piece dry-sump tank there.
Very interesting design. It's kind of like
we had to
offset.
This sits up in the car this way, like this. This holds about 7 litres of oil up to about here.
Yeah.
And then plus all the oil in the lines and the cooler and the filter and stuff. So it's probably going to be around about 8.5, 9 litres of oil in it. This is fully baffled, stop the oil sloshing around. But we had to make it in 2 passes. This is machined from billet aluminium. This is billet aluminium, and then it's welded together, pressure tested, leak tested. But this goes into the car. Return oil into here and feed to the dry sump pump down here. And then some scavenge ports for the recovering the oil from the engine. So yeah.
And just so people understand, this is actually going to sit right here, yeah?
Yeah, it has to be that staggered design because part of it has to be round here and then another part of it has to be round down there. So we had to have this offset two-piece design because I don't want to put it in the car because it's a road car. We can't have hot oil in the car with passengers in there. Some of the other areas are space claimed already for filters, electric motors for power steering pump. So that was the logical place to put it. Could have put it in the boot of the car, but again, I don't like oil lines in the car and the ability to, primarily things have to be safe. So the reality, it'd probably be just fine, but the oil lines get hot and you don't want to be in a car getting hot when you don't really want to be hot. Yeah. So that's where it's going over there.
So that's the intake side, and you mentioned it's going to be a twin injector setup.
Yeah, so we're doing a 12 injector setup. We're going to validate the engine on 12 injector setup, but we can test it with 6 and 6 if we want to. Fuel system is fully compliant for E85 if we want to go to E85, flex fuel sensor. Engine will be controlled by Mtron. We were going to go with Motec, but we decided in conversation with JHH Racing that we're going to go with the Mtron side of things. 3.6 configuration. Headline RPM figure is going to be 10,000, but we don't expect to have the engine that hard. We want tractability, high torque characteristics. We want it to be we don't want it to be a peaky race engine. We want it to be very tractable. Think like drive to the, you've got 100 litres of fuel in a car, and where am I going to go? And I'm going to start driving. I'm going to go to the south of France or wherever. So, you need to have a car that's reliable, is tractable. Obviously, with the M20 ECU gives us all the safety factors, things like warming up the engine because it's billet. We can restrict the revs due to engine temperature. All of these things. So, we're going to work on that, work through that. But JHH Racing have been given the brief of what we expect from them. They understand that, and they're working towards that. We will go out sometime middle of next year to go and watch the dyno runs. And sign off on the engine. They can ship it in a crate. This engine configuration you see here, we're going to send to them in a crate with all the other parts that go with it.
And I guess we have to talk about the exhaust, or rather the manifold side of things.
So the exhaust manifold is quite an interesting piece. So obviously,
that's the space you have available.
Yeah, we have this space available here, and we have to drop through there. We're going with a 6-into-1 configuration. We're working with a company in the Netherlands called Celeritech, a good company to work with, very thorough and diligent. So they're manufacturing it from Inconel. We have 3D printed stainless exhaust stubs with EGT bosses in there.
So best of the best.
Yeah, it's certainly a nice system. Obviously, titanium exhaust manifolds are not great for cracking. So we're going to go from the collector back will be full stainless. So from the collector forwards is all Inconel. We had to swap the alternator to the right-hand side of the engine because the dry sump pump has to go down the side of the block and underneath the engine mount.
All right, yeah. And the engine mounts alone are just beefy as hell.
Well, the engine is, as mentioned previously, is chassis mounted. Yeah. So we don't want it to move anywhere. So it's solidly mounted.
Solid.
It has rubber bushings in it, but we understand that there's going to be some vibration.
Yeah.
but we try to minimise that as much as possible. But also, you know, it stiffens up the front of the car as well. You know, we have power aspirations, but for us, it's not necessarily the headline figure. It's more about the tractability and the drivability of the engine. That's what we've said to them. We want it to be.
Which is pretty much on point with the S30 World philosophy. That, you know, it's all about getting the most out of a car. Nice spread of torque, easy to kind of live with.
Yeah, that's you know, it needs to be trouble-free. It's not a racing car. It's not a race engine. Although the bones of it are very much in a racing side of life. But you know, we're gonna this architecture with the block and the cylinder head is, you know, it's destined for like 3,000 brake horsepower in Australia. You know, 100 psi boost to it. So we're very much under stressing it. But the selection of the engine block, it just goes back to the lightness. You know, it's if you put an RB26 block or an RB30 block next to a billet RB30, you're 45, 50 kilos lighter already. And what's interesting when you look at the position of the engine in the car, bearing in mind that this is an RB30 block, so it's 4.5 centimetres taller than an RB26. It sits very low in the car.
It sits extremely low, yeah.
Like, we can't go back too much further here because we potentially may have to put a cylinder head drain in it. But because we're using dry-sumped and the engine will run under vacuum, we might not necessarily have to put a cylinder head drain there, because these engines are high RPM, are prone to pooling oil in the cylinder head, doesn't return back to the sump quickly enough. But yeah, we just keep thinking about what it's going to sound like at maximum RPM.
I can't wait to hear it. This is going to be absolutely incredible.
So hopefully come June, July next year, we'll find out for ourselves.
One other thing I wanted to touch on is the fact that you guys, well, we saw underneath before, but you went for a full AP Racing pedal box. So it actually adjusts.
Yeah. So what we wanted to do, we wanted to place the driver as far back in the car as possible and as low down. And to do that, there's a couple of reasons. We obviously need to be able to move the pedals backwards, because the seat will largely be fixed for most likely Chris. So we needed to be able to move the pedals backwards. Chris himself has got quite long arms, so the position of the steering is will change ever so slightly, because what we need to do is we just need to modify this sheet metal slightly to move this up a little bit, because you can see where the brake pedal is quite close to it. So with the standard setup, you have all of this bracketry and steel pressings here, and that all take up a lot of weight. So the idea was to go with a very lightweight pedal box. This is what they call a pulled style. So what you have is the brake pedal, and it's actually pulling on the master cylinders, which are under here. Drive-by-wire throttle. So
and of course it's fully adjustable to get that driving position.
So the whole thing slides backwards and forwards. That's it, it's max forwards, and this is it, it's max back. This is just temporary. We'll have like a very lightweight nylon, you know, strap type thing, like a Porsche RS door pull or something like that. Because you'll end up kicking it off with your foot, so you just want something that's flexible there, and it gives you somewhere where you can keep your sunglasses if you want to.
And one thing I actually wanted to show is the chunkiness of the tension rods, front tension rods here. Like, I don't think I've ever seen anything this beefy ever. And you were saying all those rose joints are preloaded, so they're...
Yeah, these rose joints are preloaded, so they're stiffer to operate than a normal one, to give some bit more firmer ride rather than a normal one that's easy to... But it's interesting the use of materials. So we have all of the aluminium parts on the car are 70-75, so high strength, lightweight. Titanium here on the turnbuckles and the lock nuts. So yeah, we've really focused on the details and the lightness of the car.
Again, the best of the best.
Well, we believe so. It's an unusual vehicle that we think is a bit unique in the S30, probably the wrong thing, the S30 world, but in the Datsun community.
Well, you know, like I mentioned in the introduction, like I don't think anybody's ever taken an S30 to this level ever. So it's going to be interesting to see how it all kind of materializes.
It's very interesting because obviously you have a lot of cars in Japan, obviously, and you're more you're far better placed to talk about it than I, but you just don't know what these guys are doing. You see stuff comes to the internet every day, and it's like...
Yeah, there's surprises once in a while,
Yeah,
but to see everything kind of concentrated into one single car, one project, I think, yeah, you guys are onto something really special. Right down, like, I mean, we talked about it before, but you have a carbon fiber roof here. That's, I guess, is going to get bonded.
Yeah, that'll get, I mean, that's just placed in position. I mean, we have to cut the roof off to weld the cage. So
You can
to be able to weld around the cage and do it properly, you have to take the roof off. So why put a steel roof on it? Yeah, exactly. This is made by our...
And you're also doing the rear hatch in carbon, yeah?
Yeah, the tailgate is also carbon fibre. Again, just for lightweight reasons. It's very light. It's got no weight to it at all. But it, you know, with our partner, we've really focused on the fitment. A lot of these components are available already in different companies all around the world, but we've tried them on other cars and they just don't fit right.
Yeah.
So we're fortunate enough here at S30 World to have quite a large repository of new old stock parts that Chris has collected over the last 5, 6, 7, 8 years.
Yeah.
So all the moulds for the roof, the wings, the bonnet, the tailgate are all from new old stock panels.
Yeah.
So you're 90% of the way there to getting it to be as close to OEM as possible. You know, there's always going to be some fettling, some requirements, but ultimately, you know, it's a good starting point.
Incredible. And I see these really thick gauge braided hoses coming off the dampers.
Yeah, this is for the remote reservoirs. So the remote reservoirs are here. So these are Staubli dry brake connectors. You can place these anywhere in the car. So you've got the adjustment for high and low speed bump and rebound. The stiffening of the dampers themselves is electronically done from inside the car. But these will be mounted using these brackets here.
Oh, more billet parts. Oh my god, beautiful.
So these go together like this. And that will clamp across somewhere.
Yeah.
This goes around the roll cage tube.
Yeah.
And they'll fix. They'll probably go on this down tube here. But yeah,
That's
all the tubing is the same diameter. So with this diameter, you're free to mount them where you are.
Yeah.
But again, you know, it's lightweight, but it's quite. I think it's quite beautiful to look at.
And then with these fittings, you're able to keep the pressure separated. So
Yeah. So they're basically they're an aerospace type connector. So when you're compressing it, there's a valve inside that won't allow the pressure that's in the canister to leak out and the oil. So you know, you don't necessarily have to have this. You can have this directly to here. Yeah. But this gives you more. You can put these wherever you want to, and also this is quite difficult to get through the top mount hole. They just don't fit. So it's easier to do it this way. It's more expensive, obviously, but it's easier to do it that way. And also, it looks nice in the car, and it's easy for access to change it.
Gives that motorsport feel about it.
Yeah, I mean, for me, it's more of a practicality thing. It's right there, and you know, if I want to change this and I want to change that, I can do it very quickly.
Yeah.
Because the intention is that, from the outset, our discussions with Intrax. So Donald Molinar and his team at Intrax there. Donald is an ex-racing driver. He's a very fast driver, and he's gonna benchmark the car for us. We're gonna take to Zandvoort, and which is in the north of the country.
Set it up.
And set it up and do some laps there. A few days just spanking it around there.
Amazing. In the corner you have the Watanabe. I guess they're referred to as the Gotti wheels, but they're replicas, of course, of the Gotti design. And they're made in magnesium.
Yeah, they're magnesium. Yeah. They were quite helpful with us in sharing information.
So they clear all the setup that you guys have here with the braking.
Yeah, they fit. We made some very light wheel spaces just in case we needed them, but we don't need to use them. So, but yeah, it's that whole combination of our design, AP Racing, all the information that they shared, the information from Gotti for the inside diameters, because they cast the wheels and then they machine them all on the inside, so they can control the diameters. So I basically took the world's most complicated drawing I've ever seen, because they don't just do one drawing for one wheel size, they do one drawing for all of the wheel sizes. So you get this drawing and it's like, oh, you know, it's got this wheel, this wheel, this wheel, and it's just. But I unpicked it, and yeah, they fit just fine, no issues.
Nice.
But
That's gonna look really cool.
They took a long time to come.
Yeah.
But then, you know, if you got, having seen some of the videos on Watanabe on YouTube and stuff, you can.
Well, we went to visit them.
Yeah, I watched your video, and it was. You can see why they take a bit of time to come.
Yeah.
But they're worth the wait. I mean,
Yeah, people really appreciate like the old school kind of approach still in today's day and age.
Yeah.
Still
I mean,
doing
this
videos
car's
like-
going to be dark green with the dark anthracite wheel. It would just set it off.
Beautiful. Well, thank you so much for running me through every single detail possible.
I hope I.
Now we just have to come back when it's close to being.
You're more than welcome.
Yeah.
We'll send you videos of the engine running. And
Awesome. Thank you so much.
no, thank you for coming.
All right, I guess that wraps up this crazy in-depth look at Chris's wild project. I think what he's doing is pretty crazy. I mean, he's definitely a madman for even attempting to create something so special out of an S30. But these are the projects that we love. It's such a passion-driven project, years in the making. I mean, he's really making sure that he hits every single detail at the highest level of quality, and you know, basically the modern take on an older car. All the components, custom made, custom designed, like really involving the best companies out there here in Europe and having an approach that's very much unlike what we're used to seeing in Japan. And I think the end car is going to be something extremely special. I don't think anything like this has ever been attempted. We're going to be keeping in touch with Chris. We're going to be back in Holland following the car as it gets closer to production in 2026. And hopefully bring you that first drive, because I think like most of you there watching, you know, just hearing this RB36 NA scream through a set of Inconel manifolds is going to be something special. So yeah, make sure you check back soon for more. And of course, hit that subscribe button. It really does help us stand out on YouTube and the algorithm. That said, hope you enjoyed this one, and we'll be back soon for more.